Radioactive elements can spontaneously emit three different types of radiation: alpha particles, beta particles, and gamma rays. Click on one of the buttons to see animations of different types of radioactive decay. Carbon-14 spontaneously emits beta particles from its nuclei. Since beta particles are attracted to the positive plate of an applied electric field, they must be negatively charged. In fact, beta particles are electrons that are formed and then emitted from the nuclei of certain radioactive isotopes. In the decay process, a neutron is converted to a proton and a beta particle. A carbon-14 nucleus contains 6 protons and 8 neutrons. During beta decay, one of the neutrons is converted to a proton and an electron. This electron, called a beta particle, is then ejected from the nucleus, producing nitrogen-14. A nitrogen-14 nucleus is stable. Thus, no further radioactive decay occurs. Cobalt-60 is used for radiation therapy in treating certain cancers. It spontaneously emits gamma rays from its nuclei. Since gamma rays are undeflected by an applied electrical field, they have no electrical charge. Gamma rays are very high-energy electromagnetic radiation. They have no detectable charge or mass. A cobalt-60 nucleus contains 27 protons and 33 neutrons. When a gamma ray is emitted, the number of protons and neutrons in the nucleus is unchanged. The half-life for this process is 5.26 years. This means that half of a given sample will undergo this process every 5.26 years. Radon-222 is being formed continuously in our environment by decay of uranium-238. Radon, being a noble gas, is chemically unreactive. Therefore, it is not trapped by chemical processes in the soil or water, and is free to seep up from the ground and into homes. Radon spontaneously emits alpha particles from its nuclei. Since alpha particles are attracted to the negative plate of an applied electrical field, they must be positively charged. A radon-222 nucleus contains 86 protons and 136 neutrons. During alpha particle emission, a particle composed of 2 protons and 2 neutrons is emitted. An alpha particle is equivalent to a helium-4 nucleus. When an alpha particle is emitted from a radon-222 nucleus, a polonium isotope, polonium-218, is produced. Since an alpha particle contains 2 protons, the atomic number decreases by 2, from 86 to 84. An alpha particle has a mass number of 4, so the mass number decreases from 222 to 218. The polonium-218 isotope produced is unstable, and therefore undergoes further radioactive decay. Both alpha and beta particles are deflected by an applied electrical field, while gamma rays are unaffected. Also note that alpha particles are deflected less by the applied electrical field compared to beta particles due to their higher mass. An alpha particle composed of 2 protons and 2 neutrons is approximately 7,000 times the mass of a beta particle.